Okay, so in this video we're going to have a look at a divisibility proof by induction. So again, we have our steps from our previous video. So in step 1 we're going to prove true, and we just have a look here. They've said for all n element of n, so we can start on 1. So we're going to prove true for n equals 1. So anywhere I see n now, I replace it with 1, 6 to the power 1 minus 1. So that's 6 minus 1, which gives me 5. And then we get 5 is divisible by 5. This straight line here just means divisibility. So true for n equals 1. Step 2 then, we're going to assume true for n equals k. So we get 6 to the power k minus 1. So that's 6 to the power k minus 1. And because it's divisible by 5, so the only time we'll do this step here is for divisibility proof. So we'll let this equal 5a, because if 5 divides into it, then a just represents any multiple. So it could be divisible by 5, this could equate to 10, 15, 20 and so on. So we just add a in to account for that. And we say a is an element of z, positive or negative integer. Okay, so what I'm going to do, always in a divisibility proof, you can leave a line here free because we'll come back and rewrite this. You'll see now why in a second. And our third step, we're going to prove true for n equals k plus 1. So we get 6 to the power k plus 1 minus 1. Indice rules lets me rewrite my first part, so that's 6 to the power k. The dot means multiplication, multiplied by 6 to the power 1 minus 1. And then all we have to do here now is a little bit of rearranging. So we're going to have 6 times 6 to the power k minus 1. And now what I want to do then is this 6 here, I'm going to split it up into 5 plus 1. So we'll get, and just to show you, we'll come back to our step 2 here. So we'll have 6 to the power k minus 1 equals 5a. Then 6 to the power k will equal 5a plus 1. And this step now is where I'm going to sub in. So we get 6 on 5a plus 1 minus 1. You might prefer to swap this out for brackets. So you get 6 on 5a plus 1 minus 1. So that's 6 multiplied by 5a plus 6 multiplied by 1 minus 1. Again, I'm oversimplifying a little here. You can tighten this up to maybe about 4 or 5 steps. So we'll keep this 6 by 5a plus 6 ones are 6 minus 1. That'll give me 6 times 5a plus 5. Now what I want to do is rewrite this where I've factorized out by 5. So I have a 5 here and a 5 here. So that gives me 5 on 6a. Sorry, where are we? 5 on 6a plus 1. So we can say true for n equals k plus 1 as 5 is a factor of 5 times 6a plus 1. And if it's a factor of it, then it divides into it. So there's our divisibility proof linked back in. So our statement at the end to get us our final couple of marks, 2-3 marks it's worth. So we need to say 6 to the power of n. You always return back to what they gave you, is divisible by 5 for all n is an element of n. So we have prove true for n equals 1 and n equals k plus 1, assuming true for n equals k. Okay, so there's our divisibility proof answered, and that's us done for that example.